So here we're going to be looking at the efficient use of inputs in an Edgeworth box, and this is from my textbook in microeconomics. I'm Rickard Friberg. So in previous figures, we showed how we can use an Edgeworth box to look at trade between two individuals, allocation of goods, so striving towards efficiency in consumption. Okay. We can also use an Edgeworth box to look at efficiency in production. Are the inputs, the production factors, used in the right way? Okay. So to illustrate the usefulness of such an approach, let's look at a simple kind of setting. We could, in a very stylized way, think of it as representing a situation for a country, say England in the 1800s or whatever you would like. That's starting out on a process of industrialization. Okay. So we have, instead of two people, we have two industries, two sectors. So think of them as manufacturing. So manufacturing is one of these sectors. So doing goods, bicycles, pots and pans. They use instead of two goods sort of for consumption as we did before, we're now thinking of the different inputs. So think of one input being labor, the amount of labor used in manufacturing. The further right along the horizontal axis, the more labor is used in manufacturing in this economy. And along the vertical axis, we're measuring the amount of capital used in manufacturing. Okay, there's another industry, so call that agriculture. So up here we have the origin for agriculture. And similarly, we're measuring capital on the vertical axis and labor on the horizontal axis for agriculture. Okay, so think of an original allocation like here, with a lot of capital in manufacturing and a lot of labor in agriculture. And just as for goods, this is saying all the goods or all the factors of production are used somewhere in this economy. And we're interested, can we reshuffle the factors of production across these different industries in a way such that we increase the efficiency? So instead of looking at indifference curves, we're thinking of isoquants. So remember, an isoquant, different combinations of goods that give the same quantity produced. So manufacturing, you can produce manufactured products with a lot of capital, little labor, or with a lot of labor and little capital. Okay, and the curvature of the indifference curve is saying something about the trade-off. So we want to look at an indifference curve that passes through the original allocation. Similarly, we have isoquants in green for agricultural production, higher isoquants further from the origin for agricultural production are associated with higher quantities, and similarly for manufacturing. The further we move from the manufacturing origin, the higher are the associated quantities. So the question here is, point like O, an allocation like O, are there potential Pareto improvements? Can we have more efficient allocations than this? And then the answer is going to be yes. We could follow the same logic as we did with exchange of goods. But let us instead extend the analysis a bit compared to what we did before and introduce a relative price of the factors of production. So this is W over R, the slope of the isocost. Maybe write that. Or minus W over R. We disregard minus and plus sign since we're interested in the tangency points here. Okay, what's the slope of the isoquants? Well, remember here, again, looking at the absolute value of this, but I don't write it, slope of isoquant. It's given by the ratio of the marginal products. So right here, so this is the marginal product of labor over the marginal product of capital in manufacturing. So in a point like this, where it's very little labor in manufacturing, lots of capital, so very few workers are, chasing a lot of capital in some sense, and vice versa. In agriculture, marginal product of labor is very low. There's tons of people out on the fields. There's some very rudimentary machinery, lots of people, a low marginal product of labor relative to capital, whereas in the manufacturing industry, there's a very high marginal product of labor. Okay, so moving workers from agriculture to manufacturing would be associated with an efficiency gain. They would yield much more in some sense in manufacturing than what they do in agriculture on the margin, given how many people are already in manufacturing or already in agriculture, sorry. So the question is, do we need a social planner to organize this reshuffling in some sense? Well, in the perfectly competitive economy, the answer is no. Since all the firms here, if they're cost minimizing, they're facing the same input prices, they're facing the same wages, they're facing the same capital costs. So what do we know? Well, we know that if they're cost minimizing, they will choose a point at which the ratio of marginal product of labor over marginal product of capital is equal to wages over the rental rate of capital. Okay, so they will work towards a tangency point. We can illustrate such a tendency point. So say so moving people out, so some capital moving out from manufacturing and into agriculture, people moving from agriculture and into manufacturing, sorry, showing that way, we would reach a new point like here. This is not looking great, but you get the point. So point like N here. So what do we see? What characterizes this? Well, firms observed the wages and rental rate of capital, cost minimized, which led us to move from a original allocation like O to an allocation like N that is associated with a higher isoquant for manufacturing and a higher isoquant for agriculture. Resources are used more efficiently, okay? And in a nutshell, when the marginal product of labor was low or high relative to capital in manufacturing, whereas the wage was not that high in relative to the rental rate of capital. Thus, it made sense for manufacturing firms to use more labor and less capital. Okay, so saying something about how resources are allocated in well-functioning input markets.